It is our great pleasure to have Dr. Simone Severini, a very good friend of mine from the academia domain, to talk about the content efforts at Amazon. Simone is the director of content computing at Amazon Web Services, responsible for designing and delivering the content strategies at AWS. His contribution so far includes the Amazon Bracket, the content computing service, the AWS Center for Content Computing Research and Development Organization at Caltech, USA, and the Amazon Content Solution Lab. Before joining Amazon, Dr. Severini is a professor at the University of College London, where he helped to start the QCL Content Science and Technology Institute, and had many industrial projects with companies including Google, Lockheed Martin, and Siemens. He also held advisory roles in the public sector's private equities funds and some of the world's first content technology startups, including Cambridge Content, GTN, Facecraft, and QNI. Simone is an old veteran in the field of content information and science. He got his PhD from University of Bristol at UK, supervised by Professor Richard Josa, the inventor of the famous Deutsch-Josa algorithms. If I'm not mistaken, Simone is the first PhD student from Richard. Simone is an expert in combinatorics and graph theories. He has successfully used these mathematical tools in solving fundamental content information and computing problems. With no further ado, let's welcome Dr. Simone Severini. The floor is yours.
Thank you. Good afternoon, everyone. I don't deserve the very kind introduction of Min-Shu Shea. I am in the time zone of Seattle, so for me it's now 9:30 p.m. in the night, but I believe that the largest number of attendants are in China Standard Time, CST, so it's afternoon there. The title of my talk is 10 things to know about quantum computing on AWS. And before everything else, I would like really to express my gratitude to the organizers of this meeting for giving me the opportunity to talk today. And in particular, I would like to say thanks again to my friend Min-Shu Shea for his kind invitation. So the very first point that I would like to talk about is long-term vision. So we have a long-term vision. So indeed, the very first point that I would like to talk about is the importance of having a long-term vision in quantum computing, for quantum computing. In fact, while this technology is exciting and is evolving very fast in many parallel directions, it's also important to set the right expectations. So right now, quantum computing still needs a lot of scientific discovery and engineering work. There is no major theoretical blocker to realize the long-term promise, the long-term potential of quantum computers as far as science knows. But on the other side, there is a lot of uncertainty when it comes to figure out how to build scalable quantum computers, when it comes to articulate usable use cases, impactful use cases. And quantum computing is also part of a much broader set of technologies that use quantum mechanics, and any innovation in this broader set of technologies could positively impact quantum computing itself. Now, in my opinion, in order to really move forward in quantum computing, we need a long-term vision. We need many collaboration bridges within the community, between academia and industry, for example. We need transparency when we talk to stakeholders, when we talk to customers and the general public. And this is a picture that I like particularly when we think about using quantum computers for bringing benefit to business. We must not forget the elephant in the room. So sometimes something that we tend to forget given the fast pace of innovation and the growing amount of interest outside of academic laboratories. Now, quantum advantage, by definition, occurs when a quantum computer can solve a problem with some benefit beyond what classical, or by using another term, what traditional computers can do. Well, it's important to remember that nobody knows the timeline for quantum advantage in business. And however, I also like a sentence by Michele Mosca, a veteran in quantum information and computation, which says something like, while it's hard to predict which sectors are going to be disrupted the most by quantum computing, or when the disruption will happen, there is also great risk in being caught off guard, and there is great opportunity in managing the uncertainties wisely. So long-term vision is important, but also urgency in keeping an eye on quantum computing as this technology continues to evolve. My second point, a point that for me is very important, is what customers say they want when they talk to us. Most of what we built at AWS starts from customers. We discuss customers' pain points and innovate together with our customers or on behalf of our customers. And when it comes to quantum computing, given the very early days of this technology, customers want to know as much as possible if and when quantum computing will impact their business. And if the answer to this question is yes, at some point quantum computers will be impactful in your business, then customers want to engage with technology and want to get closer to the technology. They want to learn more. They want to know more about the technology. Now, some customers will want to build business application or scientific knowledge related to quantum computing. Some customers want to have the confidence in investing. Some customers want to access hardware, even if the current hardware is still in a primitive phase. Some customers want to see where hardware is at the moment, but are not sure about what hardware they want to use, explore, because of course the technology is evolving fast and in multiple directions. And in fact, as you know, there are many ways to build quantum computers. So customers don't want to commit upfront capital if possible. And finally, a number of customers already have complex pipelines on AWS and want quantum computers to be fully integrated in the cloud. And they want a fully managed experience. So on the basis of this consideration, what can AWS contribute? How can AWS work to become ready for quantum computers of the future together with our customers? How can we help accelerating innovation in quantum computing and quantum information, even if the timeline somehow is so uncertain? And here is my third point. Number 3, what can AWS contribute? What are we building? So we think that the cloud and the attributes of the cloud can bring some value to the quantum computing industry. So we believe we can contribute, and also because you see, we have learned a lot about bringing new technologies to market. See, for example, insight from other technologies like machine learning. We got feedback from a very diverse set of customers. We have learned a lot how machine learning evolved, how Internet of Things, IoT evolved, how robotics evolved during the last 10 years at least. And we have a lot of customers that are now bringing these technologies to market. So can we use what we are learning? Can we use our experience to understand how to bring quantum technologies to market? And so I would like to tell you what we are building right now on the basis of our conversation with customers, on the basis that we want to accelerate quantum computing as a technology. So we decided to work in 3 parallel initiatives that somehow are connected with each other. The first initiative is Amazon Bracket. So Amazon Bracket is a tool that everyone can use today, is in general availability. Amazon Bracket is an AWS fully managed quantum computing service designed to help accelerate scientific research and software development for quantum computing. Amazon Bracket provides a set of hardware agnostic developer tools, classical quantum circuit simulators, and access to a variety of quantum computers on the AWS cloud to enable users to build, test, run their quantum algorithms. So this is on demand, available today, and pay as you go. The second things that we started is the Amazon Quantum Solutions Lab. So the Amazon Quantum Solution Lab, it's an organization that helps customers engaging with the technology. And the Amazon Quantum Solution Lab is a team of subject matter experts in quantum computing whose mission is to help AWS customers accelerate their use of quantum technologies in their products and operations in the future, of course. And we run collaborative research programs using our expertise in quantum computing, but also machine learning and HPC, high performance computing. The third initiative that we started is the AWS Center for Quantum Computing. This is a research organization, a team with the goal of building a fault-tolerant quantum computer. We started the AWS Center because we want to learn as much as possible about quantum hardware, and we want to contribute accelerating innovation at the hardware level. In parallel, while we try to understand the best ways to integrate quantum computers on the AWS cloud and offer quantum computers to our customers. Now, let me tell you something about Amazon Bracket, the AWS quantum computing service. This is my point 4. In this slide, you see on top 3 categories: build on Bracket, research on Bracket, teach on Bracket. Who is building on Bracket? Industry, solution providers, researchers are researching on Bracket, and educators from academia are teaching using Bracket. Now, in this middle diagram, there are multiple properties, multiple parts and possibilities that are important for our customers when they use Amazon Bracket and what Amazon Bracket offers to customers. You see, from the perspective of researchers, users, and developers, Amazon Bracket tries to solve 3 problems. First, access to different types of hardware. Second, integration of quantum resources and non-quantum resources and services, because the interplay between quantum and classical resources is important. And third, Amazon Bracket offers a consistent experience, operational performance, which is not easy to realize and something which we have a lot of experience. And there is also benefit for hardware providers, because hardware builders, people that are building quantum computers and have their machine of Bracket, they have Bracket as a route to customers, and also Brackets enables them to focus on building quantum hardware rather than infrastructure and services, which is valuable because their ultimate goal is to build quantum hardware and not to think about operational consistency, for example, or technical supports or security and privacy. Here, it's an architecture diagram of Amazon Bracket. On the left, there are users, then ways that user use for interacting with the service. So user can work, for example, with managed notebooks. User can access multiple quantum circuit simulators. In fact, 3 quantum circuit simulators, which we call SV1, TN1, and DM1 in the orange box. And these are just a Schrödinger simulator for simulating quantum circuits, a tensor network simulator for simulating quantum circuits, usually with special structure, and then a simulator for adding noise models to quantum circuits. And simulators are used for researchers that are exploring quantum computing and are doing science. But users can also access real quantum hardware. So users can code, test, simulate, monitor, analyze what they're doing in the service. And an important point is the integration with AWS Cloud. In fact, Amazon Braket uses other services. For example, Amazon S3 for storage, or AWS Identity and Access Management for permissions. And you see that the innovation is that when we started building Amazon Braket, we had to learn how to integrate securely a quantum computer on the cloud. And this experience so far gave us a lot of deeper understanding of what it means to integrate quantum computers in a complex IT infrastructure. So we learned a lot since that point. Let me go to the next point. This is point 5. Let me tell you briefly what kind of quantum hardware is currently available on Amazon Braket. Right now, if you log in the console of AWS, you can use 3 different types of quantum computers on Amazon Braket. We want to give customers different choices, as we do with classical hardware. And here, we have 3 different types of hardware in general availability since August 2020, so over 12 months. So this is hardware built by a startup which is based in Vancouver, Canada, called D-Wave. And D-Wave built some quantum annealers. These are machines that are suitable to solve certain specific optimization problems. The second machine is a device built by a startup based in Maryland, in the US, called IonQ. And this is a quantum computer based on ion traps. And third machine is a device built by a startup called Rigetti, which is based in Berkeley, in the Bay Area, in California, in the US. And this machine specifically uses superconducting qubits. This hardware is available now on demand, pay as you go. So no upfront cost, no commitments. And these are computers built with different technologies, which is interesting. So user can explore from the same uniform environment different type of machines with different physical implementations. And so users can keep an eye on the evolution of technology and see how the technology is evolving with respect to different kind of physical implementation. But last week at reInvent, the AWS annual conference, we also announced that we are working on the integration of processors built by 2 other startups, OQC, which is Oxford Quantum Circuits, and by QEra. Oxford Quantum Circuit is a UK-based startup, and they have their own twist on gate-based superconducting processor. This is the so-called CoaXMon. This is in Europe. And I hope that what we are doing together with Oxford Quantum Circuit will support positively the UK quantum technologies landscape. And QEra is a startup in the Boston area, close to Harvard and MIT, and they built a different type of processors based on Rydberg atoms, neutral atoms. This is well suited for simulating a variety of natural systems and for working in something called analog Hamiltonian simulation. And there is already exciting research in that field. And I'm very much excited that excited to welcome both this new hardware to Amazon Braket, and I'm looking forward to have them available on the service in the next future. So this to say that Amazon Braket offers different types of quantum computers and an environment for working with quantum computers for simulation but also real quantum hardware, and fully integrated in the Amazon cloud, so using other services. Another thing that we launched recently, in fact, at reInvent again last week, is a feature of Amazon Braket, which is called Amazon Braket Hybrid Jobs. Right now, there is lots of discussion out there in the scientific community about what to do with quantum computers in this current phase. So this phase is called NISQ, Noisy Intermediate Scale Quantum, meaning that the quantum computers available today are not error corrected. Maybe there are some mechanisms for doing some error mitigation via software, but there's no hardware error correction. And it's still unclear whether quantum computers in this phase, in this NISQ phase, can bring some quantum advantage. So, of course, there are some experiments out there that show that these quantum computers are very interesting, important devices already for scientific purposes. But to explore, to help customers and researchers exploring quantum computers in the NISQ phase, we added these features to Amazon Braket called Amazon Braket Hybrid Jobs. So what does this do? So it's generally available, first of all, in all regions where Amazon Braket is available, and it can be used with all quantum devices and simulators on Amazon Braket. Now, before hybrid jobs, through Amazon Braket, customers could submit some tasks to simulators or quantum hardware, and then classical hardware, and go back and forth for these algorithms that require many iterations, even hundreds, if not thousands of iterations of quantum and the classical computer, back and forth. And with Amazon Braket Hybrid Jobs, we manage this interaction. So we have introduced some kind of job instance, and this is some classical machine on the cloud that is responsible for orchestrating the interaction between the classical and the quantum resources. And this is very customizable, meaning that you can create your custom containers for the ones among you that are familiar with some software engineering terminology for this specific job instance. And you can monitor progress of your algorithms, and whenever you run, for example, variational algorithms, these are called quantum classical algorithms that use a quantum computer and a classical computer back and forth. You may want to monitor what is happening because you're looking for convergence towards some final circuit, which will be what you really want to build at the end of the computation. So you can adjust in case the computation on the fly by monitoring what is happening. Also, for the duration of the algorithm, a hybrid job has priority access for the selected quantum hardware, and this ensures faster and more predictable performance for customers. So this is a tool that even in this early stage, where quantum computers do not have clear applications, it could be potentially useful to explore what to do with quantum computers and help people using quantum computers. And one reason, you see, why it makes sense to be on the cloud when working with quantum computers is that in the long run, we envision that there will be QPUs, like quantum processing units, but then CPUs and GPUs, right? And these macro compute resources beyond quantum classical algorithms. And for example, so-called classical post-processing, which by the way, needs to be done for a lot of quantum algorithms, even not necessarily for the hybrid algorithms. And so what we built here is about anything that use quantum and classical resources, and we need to learn as much as possible how to build that. Suppose in the future you will want to have, for example, in maybe I use a science fiction term, but let's say a digital twin of a molecule, right? I want to design a molecule in silicon rather than in the lab, and I will use a quantum computer for doing that. I will need a quantum computer, but we'll also need a lot of other type of resources. And this is where hybrid really takes over, and that is why one needs to figure out infrastructure. So Amazon Braket Hybrid Jobs is a tiny step in this direction. And here on the screen is just an example where you can create, in fact, secure and custom APIs for your user, where you can use a quantum computer, but also high performance compute, HPC, in the same environment in the AWS cloud. And I think that this is important because indeed it's a tiny step towards this idea of macro compute resources beyond quantum classical algorithms, but resources that include quantum and classical computers working together. Let me go to the next point. Innovators are building on Amazon Braket. I would like to focus a little bit on action, on what people are building on Amazon Braket. And in this page contains a number of logos from AWS partners building solutions and services. These partners belong to an organization, a network, which is called AWS Partner Network, APN. This is a global program focused on helping partners building a successful AWS-based business. And it has over 100,000 partners from over 150 countries. And in fact, over 90% of Fortune 100 companies use APN partner solutions and services. And this slide is just a sample of companies that are building on Braket or working with our professional service team. And this is about building solution, but also about building consulting services, since customers want expertise on both quantum computing and classical resources. And so let me give you two examples of what people are doing with Amazon Braket. So Q&Co is a startup in the Netherlands. They built Cubic, which is acronym for Quantum Computing Backend for Chemistry. And this is a quantum computing platform designed for chemistry and material science simulation. They have some proprietary algorithms and they run quantum classical hybrid. And they access Amazon Braket, and this service uses Amazon Braket as part of a larger AWS environment. And here is some details of an architecture diagram. You see that Amazon Braket is a detail in this architecture diagram because they use other services like Amazon Elastic Container Service, Amazon Auto Scaling Group, and this, I think it's interesting because it shows how if you want to build some service for people to explore quantum computing, for people to do specific things with quantum computers like attempting design, chemistry and material science simulation, then Amazon Braket is a tool as part of a complex environment which includes other services. Another example that I would like to present briefly is Forge, which is a service built by QCware, is a software as a service machinery built by QCware, and is specifically addressed to data scientists. So using quantum computers for data science. And here you see that a service of this type, again, would use Amazon Braket, but on AWS, being built on AWS, will use a lot of another piece of software for monitoring, for simulating, for storage, for databases, and so on. And somehow Amazon Braket leaves the complexity together with other services of building your own environment. And please, for more details, please refer to the AWS Quantum Computing blog. There is a link at the bottom of this page, or of course to the website of Q&Co and QCware. My next point is 8, Amazon Quantum Solutions Lab. I mentioned the Amazon Quantum Solution Lab at the beginning of my presentation, and this is an organization that, what does the Quantum Solutions Lab do? So we run collaborative research programs using expertise in quantum computing, machine learning, and high-performance computing. And these programs help customers research and identify the most promising application of quantum computing for their business, and get ready for when quantum computers will impact their business. And the Quantum Solutions Lab works backwards with customers from their business pain point and develop and benchmark new algorithms and solutions, first with classical state-of-the-art solution, and build internal expertise and strategy required to prepare the customer for future when quantum hardware will be available for impacting their business. And there are many benefits for customers, like the team help customers understand if and when quantum computing will help their business and solve their use cases. And together we built a roadmap to prepare the customers for the arrival of the technology and build expertise. And I think that this is important at this stage. My 9th slide is regional initiative. I just want to very, very briefly say that we are partnering with a number of organizations out there that are using Amazon Braket, and I'm very excited about this. So community is fundamental. collaboration is very important at this stage. There is still a strong scientific component when it comes to quantum computing, and it's important that people can see with their own eyes what is happening in this space to understand even what is true and what is not in an area which is very new and where lack of information is often filled by noise. So here is just a slide with some of the initiatives that we are currently running worldwide together with our partners. Now, finally, let me go to tell you a bit about our own hardware project. So this is the 10th point, my last point. We are investing in the long-term potential of quantum computing. Let me tell you what we do about hardware. In 2019, we started building an organization which is called the AWS Center for Quantum Computing. And the main facilities are in Pasadena. In fact, we have a dedicated building that we built just very recently in the campus of Caltech. And I think that this is beautiful that such a facility is in the campus of Caltech, because Caltech, first of all, is an institution with a very strong history in physics and in quantum information science, in quantum computing. But on the other side, I hope that the presence of the AWS Center for Quantum Computing at Caltech can contribute to further enrich the Caltech's context also for students, for postdocs, for researchers. Here in the slide is just a photo of the building that we just built that hosts our laboratories. And in our initiative there, we are building some NISC devices, some near-term devices, but our long-term goal is to build fault-tolerant quantum computers. So we believe that error correction is really, really important for quantum computing, and we are investing resources in the long run to achieve something related to fault-tolerant quantum computers, something that we hope can benefit on one side science, on the other side business. And let me tell you briefly about quantum error correction. You see, when you build a quantum computer is subject to noise. Like qubits are subject to noise. And you want to make sure that qubits are protected from noise. And to do that, you need to encode information in what are called logical qubits. There's physical qubits that are just the physical devices that encode quantum information, but then to protect information, you need to have redundancy and encode logical bits into an ensemble, into a set of physical qubits, which then turn out to be logical qubit. And there is a lot of overhead that is needed whenever you want to build logical qubits. It can be hundreds of physical qubits per logical qubit. Now, a potential approach here is the following. So let us try to build some hardware that tries to give some more efficient error correction, minimize the overhead. Now, many people are considering now what is called cut qubits in harmonic oscillators, and I will not describe this subject in detail here. In fact, I just mention it en passant. And the main point here is that a qubit usually is encoded in some physical object that gives 0 and 1. But then you could look at harmonic oscillators and multiple equally spaced energy levels, and instead of a qubit, so 2 levels, now you have more levels to play with and possibly get some built-in protection. And you can encode information in what are called coherent states with opposite phase, and this is called cut state, for the ones among you that are familiar with these physics terms. And you can engineer your system to protect the cut state against bit flip, one of the two errors that can happen in quantum hardware. The other one is phase flip, as you know. And look, by following this approach at our center, this is the chip that we built there, and this dashed circle is the microwave oscillator where we implemented the cut qubit, and this device has shown an experimental improvement of over 3,500 times in coherence time with respect to the case that are not used cats, with respect to bit flip lifetime of the cat. And the bit flip lifetime of the cat that we built is about 10 milliseconds. And of course, to get a logical qubit, we need also to correct phase flip errors, as I mentioned, and this is something that we are working on at the moment. I want to include here a slide for the more technically minded colleagues. They want to see some numbers. Now, this is a plot of the experiment. Actually, this is an early experiment, but it gives you a feeling about the numbers and the outcome of the experiment itself. So here you see that on the plot, the lifetime is 5.5 milliseconds, as you notice, which is less than 10. This is an earlier experiment. Of course, if you want to have more details, I'd be more than happy to put you in touch with the scientists that have run this experiment. I'm moving towards the conclusion of this presentation. I have some key takeaways. So the first one is Amazon Bracket, our quantum computing service, is available, is generally available. Everyone can use it. And I hope that this can help customers explore quantum computing, on one side researchers, but also people in industry. Second takeaway is that we committed for the long term to invest in quantum computing research at AWS. And we really believe that error correction is important. We really believe that this technology in the long run is going to be impactful, but we need to focus on the science, on the technology development, and we need to focus in having multiple parties working with each other. As I said, university and industry together, and everyone, multiple stakeholders need to have a role here. And final takeaway is customers and partners are building tools and applications. They're expanding quantum computing capabilities in the cloud. And this is interesting because in building Amazon Bracket as part of the AWS cloud, we give an opportunity to people to build something that does not only include quantum computing, but quantum computing as part of a more complex IT infrastructure. Now, here are some web links where you can find more information about this talk. I would also, in fact, I would advise mostly to look at our blog, aws.amazon.com/blogs/quantum-computing, where you can find many of the things that I presented today. And if there is an extra minute, I would like to use a final slide, which I quite like, even if in a way is not related to the presentation. So this week I was at Q2B, Quantum to Business, a conference in Santa Clara in California, and I decided to use this slide as well because I quite like it. So this is, the first week of December in 2017. So Charlie Bennett, one of the veterans in quantum information and quantum computation, was giving a talk in a conference in Beijing, and I was there. And I took this picture actually of Charlie after the conference while we were having a cup of tea. And during this talk, he said the following phrase: "The greatest achievement of our field, which is quantum information and computation, won't be to speed up computation or to communicate secretly, but to help people understand that this world is quantum mechanical." And I like this sentence because it really gives the feeling that the deepest, most impactful innovation comes from a deeper understanding of nature, right? And possibly innovation that one day will be potentially enabled by quantum computers, in the future, is beyond what we can imagine now. And thank you all for your attention, and thank you for your time.